Hello, dear students. Today I will explain an experiment in physics that is Newton's ring experiment. In this experiment, uh, we measure the wavelength of sodium light by measuring the diameter of Newton's ring. This experiment is based on the phenomena of interference of light wave. We are familiar with interference of light wave. For this experiment, we required the apparatus, and these are sodium lamp. Sodium lamp is a monochromatic light source, and in this experiment, we will measure the wavelength of sodium light, and we know the standard value of the wavelength of sodium light is 5893 angstrom. Second apparatus is traveling microscope, and the third apparatus, that is the Newton's ring apparatus, consisting of an optically plane glass plate, convex lens, and whose radius is r is equal to 100, which is given and a glass plate movable at an angle 45 degree. In this experiment, we use a formula, and just I am going to share the whiteboard. In this experiment, we use a formula, and the formula is, just I am writing here in this whiteboard. Lambda is equal to where lambda is the wavelength of sodium light, which is a monochromatic light source, dn plus p square minus dn square divided by 4 PR. In this formula, dn plus p is the n plus pth diameter of Newton ring. This dn is the nth diameter of Newton's ring. P is any integer. It may be 5, 6, 7, 8, and you will have to choose it. And this capital R is the radius of plano-convex lens. And this Newton's ring experiment, which I am going to discuss, is for the reflected light. Now, I will discuss the experimental setup of this Newton's ring experiment. In this experimental setup, there is a source of light S. There is a source of light S and a convex lens is used. When this light starts from this source, and this source is kept at the focus of this convex lens, after refraction, this light wave becomes parallel like this. I am discussing the experimental setup of Newton's ring, and there is a glass plate. There is a glass plate G. This is a glass plate G is used when this light wave incident or falls on the glass plate, it reflects at an angle, partially reflect at an angle 90 degree. Because this glass plate G is placed vertically at 45 degree. This angle is 45 degree. This angle is 45 degree. So light beam reflects at an angle 90 degree. This is the 90 degree. Okay. After reflection, this light beam falls on the combination of plano-convex lens and a plain glass plate, this, and this is a plain glass plate P, and this is a lens, plano-convex lens. Okay, and here C is the point of contact, and the Newton's rings are formed about this point of contact C, and we can observe these Newton's ring using a microscope. We use a microscope this time. This is a diagram of experimental setup of Newton's ring. This is a microscope. Okay. Now I am drawing here the Newton's ring. I am drawing the diagram of Newton's ring. In Newton's ring, for the reflected light, the center is circular patch like this. Circular patch. Okay. Then a bright ring like this. Then dark ring. Again bright ring like this, like this. Okay. Again bright ring. Again dark ring. Again bright ring. Again dark ring. Again bright ring. Again dark ring. And there are alternate dark and bright rings are formed. But all the fringes are due to the interference of light wave. All the fringes are circular like this, alternate dark and bright ring. This is the diagram of Newton's ring. This. Okay. This figure is the experimental setup. Mental setup of Newton's ring. Experiment. This diagram is the is the Newton's ring due to reflected light. And this is the formula. Which is used to measure the wavelength of sodium light. Okay. Using this formula, lambda is equal to dn plus p square minus dn square divided by 4pr, we can measure the wavelength of sodium light. Again, I want to describe this experimental setup. In the experimental setup, extended monochrome light source, extended monochrome light source S from sodium lamp falls on a glass plate, here showing in this diagram, vertically kept at angle 45 degree. The plate reflects partially at 90 degree to lens plate combination. The plano-convex lens is in contact with glass plate P. The space, this space between L and P contains air. The thickness of this air is minimum at C because C is the point of contact. The lens is capped of a sphere and therefore air film around C will make circular locus of the air with varying thickness. If we see through the microscope, we find rings as shown in this figure here. This is the Newton's ring. Okay. Now, when you will observe the Newton's ring using this microscope, this is a microscope. This is a microscope. This is a microscope. M is a microscope. Adjust the microscope over the point of contact so that the rings are seen distinctly in the field of view as clear as possible. Set the crosswire on the center of the ring. Now we set the crosswire of the ring. This is the crosswire. Okay. Set the crosswire on the center of the rings. Okay. Using vernier screw, now move the crosswires and set on 15th bright ring on any side, maybe this side, 15th ring, bright ring. This is the first bright ring, second bright ring, third bright ring, fourth bright ring, and so on. We will put the crosswire on the 15th. It is not mandatory you will use the, we will keep the crosswire on the 15th ring. It may be 18, it may be 20. Okay, just I am giving example. And on any side, it may be here or then right side, it may be in right side. Okay. Using vernier screw, now move the crosswire and set on the 15th right ring on any side and read the vernier scale reading. Now we take the vernier scale reading. Vernier scale reading you can take uh, by knowing the list count of this macroscope. We calculate the list count of any instrument. For example, a microscope. List count is you can calculate. It is a when you will measure the one division on the linear circular scale or main scale of the macroscope, and you will divide it by the total number of division on Vernier scale. It means you can define the list count as the when you will calculate the smallest division of the main scale, and you will divide it by the total number of the division on Vernier scale, and you can easily calculate the list count. Okay. Bring the crosswire of microscope back towards the center. From here, you will come here at center. Okay. Stopping on each ring for Vernier reading. Jitne bhi rings hain, all the rings you will stop on bright ring. Continue to move on other side of the center and take similar reading on other side in increasing order of the ring until you reach the 15th ring again this side. Again, when we will reach on the 15th ring. And now you will tabulate a observation table. Just I am going to erase this diagram, and now I will tabulate a observation table. Observation table is very simple, and this observation table we will use to measure dn plus p square minus dn square. In this observation table, just I am going to draw just not this. Okay. You will draw a observation table like this. This experiment is very exciting. In observation table, first column will be the number of rings. Here you will write number of rings, number of rings, number of rings. For example, not it is necessary that I am going to write 15. You will take the 15th ring. You maybe take 18th ring. Okay. But I am writing here 15th ring. Number of ring 15. Now you will write 14. Now you will write 13. Now you will write 12. Now you will write 11, 10, and you will write here 9, 8. In second column, we write the microscope reading. Here in second column, we will know the microscope reading. Microscope, microscope. Microscope. Microscope reading. Here you will write left side, left side, and here right side. It is very easy to calculate. Sorry, side. Okay, and this third column, you will write the diameter in centimeter. Diameters. And it will be in centimeter. Knowing the left hand side reading of the 15th ring and knowing the measuring the microscope reading of 15th ring on the right hand side, and when you will take the difference, you can easily calculate the diameter of the 15th ring. Similarly, 14th ring, diameter of 14th ring, diameter of 13th ring, and so on. Okay, now you will square. Now you will square this measuring diameter. What is the diameter of the is the diameter of the 15th ring, 14th ring, 13th ring? You will take the diameter square. I am writing capital D for diameter square. What is the square of the 15th diameter? What is the square of the 14th diameter of Newton's ring? And so, okay. Now, if we take the value of P, suppose 5, then in this column, we will write here dn plus P square minus dn square. Okay, because you have chosen here P is equal to, for example, we choose the value of P 8, 5. P is equal to, I am taking P is equal to 5. It is an integer. Okay, then suppose we take the square of the 15 diameter, it will be 15. Here P is 5, then N will be here 10. It means this square, this value minus I will take this value, this 15th diameter of 15th square minus diameter of square of the diameter of the 10th ring. Okay. Similarly, when we will take the value of square of the diameter of 14th ring, then it will be suppose 14, then n will be 9. This now you will subtract this value, and using this you will subtract this value from this value. So you will get a set of dn plus p square minus dn square, and now take the average of this value. In the last column, we take the average value. Average of dn square. dn plus p square minus dn square, and you will get the value of this dn plus p square minus dn square. Good. Now, how you will calculate the value of wavelength? After measuring the value of dn plus p square minus dn square, where p is p, I am choosing here p is equal to 5, and just again I am writing here, just I am deleting this table, then I will write the formula which will be used to measure the wavelength of sodium light. Just first I will erase this. It takes more time to erase. It is very easy experiment. Hardly it will take 1 hour to perform this experiment in physics lab. In this experiment, we will use this formula, lambda is equal to dn plus p square minus dn square divided by 4 PR, and the diameters d of the ring can be tabulated from the table by taking the difference of the left hand side and right hand side reading of the same numbered ring. Square the value of the each diameter and then take the difference of these square values of the diameters, and just I discussed with some common interval of number, that is the p, but I used here p is equal to 5 of this bright ring. And now take the mean of all such values of finally have value of dn plus p square minus dn square. Putting the value of dn plus p square minus dn square from the observation table, and p is any number, any integer, and here just I discussed, I used here 5. but it may be you can use 6, 7, 8, it depends on you. And R is the radius of plano convex lens. Generally it is given. Suppose it is not given, then using a spherometer you can calculate the radius of plano convex lens. And knowing the value of R, knowing the value of dn plus p square minus dn square, we can easily measure the wavelength of sodium light. And after finding the value of wavelength of sodium light, we calculate the percentage error. How you will calculate the percentage error? Percentage error can be calculated. Percentage error can be calculated knowing the standard value and the observed value. You will take the difference and we will divide by the standard value and multiply by 100. It gives the percentage error. And so this is about the Newton's ring experiment. It is a very, very easy experiment and very exciting experiment. Thank you. Any doubt? You will contact and I will discuss. Thank you.